Nitric oxide, that's a little bit different animal. It's because air is, majority of air is nitrogen. And so when that's burning at high temperatures, you can have the nitrogen oxidized. And so it combines with, nitrogen combines with oxygen, and you get this, another substance. And this can also contribute to like smog and things like that. And this mainly occurs at high temperatures and lean mixtures. And lean mixture has more to do with high temperature. So if you add hydrogen and you advance the timing, you can get move the timing closer to the top dead center, so it would be retard the timing. And so if you do that, you'll have a reduction in NOx. But if you don't, the studies show that if you don't change the timing, then you can actually have an increase in NOx with hydrogen. These two charts are from one of the papers. The chart on the left shows the emissions without hydrogen, and the one on the right shows with hydrogen. You can see they're able to run with hydrogen much leaner, and you can still see that as they're running much leaner, you have much lower emissions. On the carbon monoxide is in the ppm scale, and with hydrogen, and it's in the percent scale without hydrogen.
What is the bottom scale?
That's the air-fuel ratio.
Air-fuel ratio?
Yeah, so that would be if you're rich or lean. So as we move this way on the chart, you're getting more lean. So in my studies, I found that there was a theoretical study on, they were trying to simulate electrolysis products in the, in a boosting versus just adding hydrogen. So first they did a computer simulation, and from that study, from the computer simulation, they found that adding 10% hydrogen and oxygen had the same effect as adding 20% hydrogen by itself. But then when they did the experimental test, they didn't find that same thing. But there was a big flaw in their test. They were worried about safety with compressing hydrogen and oxygen. So what they did, instead of getting a real electrolyzer and actually making electrolysis gas, what they did was pick a tank of air and put 2% hydrogen and 1% oxygen. And they called that electrolysis gas, and they basically said, from those results, it doesn't work.
No kidding.
That's it's a real paper. So then they took the power results from that, what they were doing there, and then they compared it to an electrolyzer that they spec'd out from some company, I'm not sure exactly, but basically I crunched the numbers on it, and the cell was about 3.5 on the MMW rating. So that's, a lot of our cells are a lot higher than that. I built a 7-cell series cell, and I was getting numbers about 6.
Can you explain the MMW for those who don't know?
The MMW is milliliters per minute per watt. And so it's basically comparing your flow rate of the gas you're producing to the amount of electrical input that you're requiring to make it.
And Faraday electrolysis is?
I haven't actually done that number. I think it's like 7, but
so that's considered maximum.
That would be like 100% on that scale. The next study, and this is the only one that I've been able to find in the technical journals on somebody actually putting a real electrolysis unit in cars and doing tests. And it's a university out of Turkey. And they had basically it was a single cell unit, had a carbon and a platinum electrode. And then they were putting 90 volts at 3 amps across the thing. And the efficiency was, 1 1/4 basically. So, but this is the encouraging thing. You look at the results, and I don't know, the study wasn't super detailed about, how they ran the tests and different things like that, but they put the unit on 4 different vehicles, and they said they did city driving tests and then did the emissions. and their results range from 25 to 40% improvement. One thing when I was thinking about this paper is, this is over in Turkey, and I don't know what kind of emissions systems they have on their vehicles. So, they probably didn't have to deal with the whole oxygen sensor and the EPI thing.
You got a hand up over there, somebody's got a question.
Yeah.
Are these diesel engines or gasoline engines?
These are gasoline engines. So this is the experimental paper, and they got positive results. So basically from this looking through the journals, I found that adding hydrogen to a gasoline or diesel engine definitely has, you can get an improvement in emissions and you can get improvement in performance. The problem is there seems to be a disconnect between the theoretical and experimental results. That one paper that's actually published, and then all of our results seem to somewhat not go along with what the conventional wisdom is. So from this study, from these papers, I concluded that we need to do universities and people who have the facilities and are used to running. I mean, as a graduate student, I run tests, and you run them multiple times, and you make sure you have a good baseline, put really good scientific principles, and have somebody who's that's their job, they're getting paid to test it, and so and not have somebody who's not biased and try to get good results. So that's what I've tried to do. The first thing I'm going to show is the first cell I built about. Well, I started out with some of the more basic designs, but in this latest research, I built a 7-cell unit off of Bob Boyce's design, and it consists of a section of the spacers that he uses for the 101 box. Then I built my own acrylic case. And here's a little video clip of me running the cell about as hard as my power supply could go.
How big of a power supply do you have?
It will go up to 30 volts, 50 amps.
30 volts, 15 amps.
But it was working earlier. Well, maybe we won't.